Cbse online classes for Ncert 10th standard and Cbse 10th standard for mathematics and science classes. So in today's session we will be going with polynomials, very important concept. So in the last class we had discussed regarding the different types of polynomials, monomials, how they are formed, binomials, trinomials, and polynomials that is of different types. So if they have a single term, that's a monomial, it's two terms. A polynomial has two terms, then it's a binomial, and say if it has three terms, it's a trinomial, and we came to the degree of the polynomial. So in the degree of the polynomial, if the variable x has degree 1, then it is called a polynomial which is of degree 1. So if it has, the variable has degree 2, that is 2 as power for the variable, then it is called a quadratic polynomial. Then we came with cubic polynomial, then we came with biquadratic polynomial. So yesterday class we have discussed all these things. So in today's session we will be learning regarding the value of a polynomial, we will be learning zero of a polynomial, and then we will be learning the most important part of the session, that is the geometrical meaning of polynomials. So how graphically or geometrically these polynomials can be presented, and how can we analyze the zeros and values of a polynomial. So in particular we are going to analyze how the zeros of the polynomial are formed. So I hope at the end of the session you will be masters in this. So in the first topic we will be going with the value of a polynomial, which you have already learned in your previous class. We will revise that once again, because based on that, today's concept, that is geometrical meaning of polynomials, that is zeros of the polynomials, is standing on it. So therefore first we will go with value of a polynomial, then we will go with zeros of a polynomial, then we will go with the geometrical meaning. Right. Okay, let us consider a polynomial p of x. So it's a polynomial in x. So what are the polynomials we are dealing in this chapter will be of same variable, that is the polynomials in one variable. In a polynomial all the variables will be x, or in a polynomial all the variables will be y, or in a polynomial all the variables will be z something, but not x, z, y, all different types of variables are not mixed in a single polynomial. So those type of polynomials we are discussing. So this is p of x. So p is the name of the polynomial and x is the variable used inside the polynomial. So let us take this. Let p of x is equal to x square minus 3x minus 4. Some polynomial is there. So now at this stage I will not discuss whether this is a polynomial or not. All those things are over. So here it is understood that whatever the examples we take in this chapter are 100% polynomials. Right. So p of x is x square minus 3x minus 4. We have a polynomial here. So we will put x is equal to 1. Let's see what happens. So in place of x, we are going to substitute that by 1, or we are going to replace x by 1. So that becomes, as we are replacing x by 1, that becomes p of 1 is equal to 1 square minus 3 into 1 minus 4. So p of 1 is equal to 1 square is 1 minus 3 minus 4. So p of 1 is equal to minus 3 minus 4 is minus 7. 1 minus 7, so p of 1 is equal to 1 minus 7 is minus 6. So here we have a value that is minus 6. So now, so here we speak about value of polynomial. So how to analyze the value of a polynomial? So now you are given with a polynomial, some polynomial you are given with, and you are asked to replace the value of x by some real number, that is 1 I have taken in this example. So as I replaced x by 1, I have got this value at the last. So in this polynomial, if x is replaced by 1, then the value of the polynomial will be equal to 6. Then the value of the polynomial equal to 6, that is minus 6. So once again, a polynomial was given to you, you replace the value of x by 1, you substituted the 1 in place of x wherever it is, and you simplified that and you have got this solution as that is minus 6. So here minus 6 is called the value of, that is the value of p of x. Minus 6 is called the value of p of x when x is equal to 1. So that's the meaning of this. So if you put x is equal to 2, the value of the polynomial changes. If you put x is equal to minus 2, the value of polynomial changes. If you put x is equal to 3 by 2, then the value of the polynomial changes. So as you go on giving values for x in the polynomial, the value of the polynomial goes on continuously changing. Let us go with another value. Let us take p of x is equal to x square minus 3x minus 4. I have taken the polynomial. So I will put x is equal to minus 2. I will take negative value here, which is also a real number. So p of minus 2 is equal to minus 2 whole square minus 3 into minus 2 minus 4. So p of minus 2 is equal to minus 2 whole square is 4, minus into minus is plus, 3 2s are 6, minus 4. So p of minus 2 is equal to plus 4 and minus 4 cancels, and the remaining is 6 here. So here the value of the polynomial is 6. So here you were given a polynomial, you substituted the value of x, y minus 2 and you simplified, you got 6 as the answer. So here 6 is called the value of this polynomial when x is equal to minus 2. So when you go on changing the values of the polynomial, that is the value of x, the value of the polynomial goes on continuously changing. So this is what we call the value of a polynomial. That's very, very simple. So this comes in your exam for 1 mark in your multiple choice questions. So you will be given a very simple polynomial. If p of x is equal to some x cube minus 3x plus 2, find the value of p of 1. So there in place of x you have to substitute 1. So in some examples, if p of x is equal to x plus 3, find the value of p of minus 2 something. So there you have to substitute minus 2 in place of x and find the value of p of minus 2. So this is how it comes. So this is a very simple thing, value of a polynomial. So once again, minus 6 is the value of this polynomial when x is equal to 1. So plus 6 is the value of this polynomial when x is equal to minus 2. So therefore, as we go on giving values for x, different real number values for x, the value of the polynomial continuously goes on changing. So it depends. Now, if p of x is a polynomial, if p of x is a polynomial and k, for example, is a real number, and k is a real number. P of x is a polynomial, that is what we have taken here, and k is a real number, that is in place of x we are substituting 1, so 1 is considered to be k, that's all. So k is a real number, so it can be anything, any value you can take. Real numbers, you know, it's a huge combination of all rational numbers and all irrational numbers taken together. They are called as real numbers. You have studied in your 9th standard classes. So k is any real number, any number you can take. So then p of k, that is we substitute the value of k in p of x, that is in place of x we put k, that is in place of x as we substituted 1 and we started simplifying that, then p of k is called value of k. P of k is called as the value of p of x when x is equal to k. So this is how you have to understand this. If p of x is a polynomial and k is any real number you can take, any real number, then p of k is called the value of p of x when x is equal to k, which is denoted by or represented by p of k. So this is the definition for the value of a polynomial. So it's very important. Now let us go with the zero of the polynomial. very important. Don't forget this. This plays a very important role for the geometrical meaning of p of x. Right. Now observe this. So p of x, let us take a polynomial here. So x square minus 3x minus 4. I have the polynomial here. So in this polynomial, let us put x is equal to minus 1. Let us substitute x is equal to minus 1. Now, when we substitute x is equal to minus 1 in this polynomial, it becomes p of minus 1 is equal to minus 1 whole square minus 3 into minus 1 minus 4. So p of minus 1 is equal to minus 1 whole square is 1, minus into minus is plus, 3 ones are, it is 3 minus 4. So p of minus 1 is equal to 1 plus 3 is 4 minus 4. So p of minus 1 is equal to 4 minus 4 is 0. So this is a very important result what we have got. So what is the difference there? Difference is there. So if in p of x in the last problem what we substituted, we got some 6 and minus 6 as values. So in this polynomial we have taken x is equal to minus 1 and we have got 0. That's all. It's not that's all. It is everything. It is that's it. It's not that's all. It is that's it. That's very important here. See here, when you have substituted the value of x is equal to minus 1 in the place, that is minus 1 in the place of x, and you simply simplify, you got 0. In the sense, you made this polynomial p of x equal to 0. You made the polynomial p of x equal to 0 by substituting x is equal to minus 1. In the sense, this minus 1 made p of x to become 0. So therefore, here as the p of x value of p of x, as it becomes equal to 0, p of x becomes equal to 0 because you substituted x is equal to minus 1. Therefore, minus 1 is called as the 0 of the polynomial. Minus 1 is called the 0 of the polynomial. So many students at this point they get confused. Right? They may say, what is this? Something like that. That may be their feelings. But actually, it's very meaningful here. You have to remember this. You had been given a polynomial. You are asked to substitute the value of x is equal to minus 1. You substituted that. You simplified. You got 0. You made p of x equal to 0. That is, p of x becomes equal to 0. So, if p of x becomes equal to 0, the value which made p of x to become 0 is minus 1. So therefore, minus 1 is called 0 of polynomial. Which is called as 0 of polynomial. You have to remember this. Right? Let us take another example. Let us take another one. So p of x is equal to x square minus 3x minus 4. We will take the polynomial. I will substitute a value. Put x is equal to 4. I will take 4 and I will substitute this. Okay, I will take minus 4. So p of minus 4 is equal to minus 4 whole square minus 3 into minus 4 minus 4. So in place of x I have substituted minus 4. So p of minus 4 is equal to minus 4 whole square is 16. Minus into minus is plus. This is minus into minus is plus, 3 4s are 12, it becomes minus 4. So let us take plus 4. Okay, 4 square is 16, minus into plus is minus here. So 3 4s it is 12 and it is minus 4. So p of minus 4 is equal to 16, minus 12 minus 4 is minus 16 again. So p of minus 4 is equal to, cancels and the value is 0. So again the things repeated here. So what happened here is, you were given a polynomial and you are asked to substitute the value of x is equal to 4. When you substituted the value of 4 in the polynomial and you simplified that, at last you have got 0 as the answer. And in the sense, you made this p of x become equal to 0. So which value made the polynomial equal to 0? That's very important question. What value of k, in the sense as I told you earlier, what value of k, that is the real number here, made the polynomial p of x equal to 0. Here x is equal to 4 made this polynomial p of x equal to 0. Right? So therefore 4 is called as 0 of polynomial. 0 of polynomial. So please remember this. So like this, how many values are there to make p of x, that is x square minus 3x minus 4 equal to 0? So here only minus 1 when substituted to this polynomial and 4 when it is substituted to this polynomial only can make p of x equal to 0 and also p of x equal to 0. Other than minus 4 and 4, minus 1 and 4, no other value of k, that is no other value of a real number apart from minus 1 and 4 can make this p of x equal to 0. So therefore for x square minus 3x minus 4, for this quadratic polynomial we have 2 zeros. We have 2 zeros. That's very important. It has 2 zeros. It doesn't have more than 2 zeros. So we usually say that for a quadratic polynomial there are at most 2 zeros. At most means maximum 2 zeros. It can also have 1 zero. It can also have no zeros. A quadratic polynomial can have no zeros. It can have 1 zero. To the maximum it can have 2 zeros only. A quadratic polynomial cannot have 3 zeros. Please remember this. So zeros of a polynomial in this concept it's very important. A polynomial was given to you, you are asked to substitute the value minus 1. When you substituted this value, p of x becomes equal to 0 only. Exactly it is equal to 0. So minus 1 made this polynomial p of x to become 0. Therefore minus 1 is called 0 of this polynomial. Maybe minus 1 may be the 0 of some other polynomial, we don't know. We don't know that. But here minus 1 is 100% the 0 of this polynomial, because when you substitute this value in this, p of x becomes 0. So in the same manner, x is equal to 4 is the 0 of the polynomial, because when it is substituted in the polynomial, it makes p of x equal to 0. Therefore 4 is also the 0 of this polynomial. So a quadratic polynomial can have at most 2 zeros. Right? That's the major statement. Quadratic polynomial can have at most 2 zeros. Okay, then it may have 1 zero also. It may have no zeros also. That's the possibility. So when I come to geometrical meaning of polynomials, I will show you how it comes, how 2 zeros comes. Okay. So this is how it goes. This is very important. You have to remember this. Right? Okay. For example, here p of x is equal to x plus 5. I have a polynomial. So it's a linear polynomial. Why it is called a linear polynomial? Because the value of, that is the exponent of the variable, is equal to 1. That is degree of the polynomial is equal to 1. Therefore it is called a linear polynomial. So now let us see how many zeros are there for this polynomial. Right? So put x is equal to minus 5. I hope you are guessing it. So p of minus 5 is equal to minus 5 plus 5. So p of minus 5 is equal to, it cancels and it is equal to 0. So you are given a polynomial, that is a linear polynomial. You substituted the value of x is equal to minus 5 in that. When you substituted the value in this value x is equal to minus 5 made this polynomial p of x become equal to 0. Therefore minus 5 is the 0 of polynomial. It's called 0 of polynomial. So like this, for this linear polynomial, how many zeros can exist? So here for a linear polynomial only 1 zero exists, because the degree of the variable here is equal to 1. Therefore 1 zero exists. So for a linear polynomial, at most there is one zero, or a linear polynomial can have no zeros also. So why here in quadratic polynomial we have two zeros? You can easily guess. The variable has the highest degree as 2 here, therefore it has at most two zeros. So can you guess for the cubic polynomial now? It's very easy. P of x is equal to x cube minus x. Some cubic polynomial is there. How many zeros are there for that? So as it is a cubic polynomial, at most there are 3 zeros. It can also have 2 zeros. It can also have 1 zero. It can also have no zeros. All the 4 possibilities are possible. So I will show you while going with the geometrical method. Okay, I hope you understood this. So we will go a little bit depth into this. I will show you how I guessed -1, and how I guessed this 4, and how here I guessed this -5. So first I will show you for the linear polynomial. So now please observe this. P of x, this is a linear polynomial. It is in the form of ax plus b. So this is the general form of a linear polynomial, what I showed you in the previous class. So ax plus b is the polynomial in x. So therefore we will equate this. Ax plus b is equal to 0. Why we should equate the linear polynomial to 0? Because if you want to get the zeros of that polynomial, you have to equate that polynomial to 0. That's very simple. So you need the value of x. So x is equal to, that is ax is equal to, plus b goes to the RHS, that becomes minus b. So x is equal to minus b by a. So this is, that is minus b by a is the 0 of this polynomial. For this polynomial, x is equal to minus b by a, if you substitute here, then you will get the 0 of that polynomial. Let us check it. We will check this. So x is minus b by a. Okay, let us go with this. So p of x is equal to a into x value is minus b by a, plus you are left with p. So p of x is equal to a into minus b is minus ab by a plus b by 1. So p of x is equal to a, and 1 is LCM is a, minus ab by a into a is minus ab, plus b by 1 into a is ab, right? So plus ab minus ab cancels. So p of x is equal to 0 by a, that becomes equal to 0. This is the most generalized form what I am showing you here, right? So in a linear polynomial, right, there will be at most only 1 0. Other than minus b by a, no value other than this. If you substitute any other value in the place of x and simplify in this polynomial, you will never get 0. That is, the polynomial will never become equal to 0. If you want the polynomial to become 0, then you have to substitute only the value, that is minus b by a. Let us do here how it comes. So p of x is equal to x plus 5. P of x is equal to x plus 5. In order to get the 0 of this polynomial, we have to equate x plus 5 to 0. Okay, I will equate this. So x is equal to minus 5. Plus 5 comes to the RHS. X is equal to minus 5. Same value I substituted here. That's all. This is how the zeros of the polynomial are present, how they are designed. So let us go with this example here. I will show you how -1 and 4 you are going to get as zeros for this quadratic polynomial, right? Let us take the quadratic polynomial. P of x is equal to x square minus 3x minus 4. So in order to get the zeros of this polynomial, I am going to substitute, that is equate the value, that is polynomial equal to 0. Let us go with the sum and product method. X square into minus 4 is minus 4x square. You have to search two numbers in such a way that if you add these two numbers, you will get minus 3x, and if you multiply those two, you should get minus 4x square. So best is minus 4x and plus 1x. So minus 4x plus 1x is minus 3x, minus into plus, minus 4 ones are 4x into x is x square. Okay, x square minus, instead of minus 3x, we will substitute these two values, minus 4x plus 1x, minus 4 is equal to 0. There are 4 terms, you can take a combination of 2 and 2 and select for the common. So here we have x as common, so x minus 4, here you can take 1 as common, plus 1 into x minus 4 is equal to 0. So here you have 2 terms, in these 2 terms you can take x minus 4 as common and you are left over with x plus 1 is equal to 0. So if m into n is equal to 0, either m should be equal to 0 or n should be equal to 0. That is, x minus 4 into x plus 1 is 0, then x minus 4 should be equal to 0 or x plus 1 should be equal to 0. Let us not take r, we will take and, as we are finding zeros. So x is equal to 4 is one of the 0 and x is equal to minus 1 is another 0. So this 4 I took it here and this minus 1 I have taken here. So this is how you get the zeros of a quadratic polynomial. So this is very important, you have to remember this concept.